Hello, trig class. We're going to look at some more trig IDs today because I was looking at your list and it's pretty small. So we're going to add to it. I noticed my battery's going. I had to run the videotape quite a while in my classes today. So I'll see how long I can tape before I'm out of battery. Title your page Sum and Difference Trig IDs. It's the 10th of November, and we'll start our ideas now. Sum and difference trig IDs. Let me see if I can make sense of this instead of just giving them to you. I don't know how well you can see from this distance, but I'm going to make a list. And these are all the sine, cosine, tangent, well, any trig function I can find of 0 degrees. Because I go on my on my unit circle at 0 degrees. I know the values of that point, 1, 0. And I can find the sine, the cosine, the tangent, and any of the 6 trig functions. So let me zoom in. I don't like being back this far. All right. So what other values do I know? Well, I know 30 degrees and 60 degrees. I know the trig functions at these points on the unit circle. I know 90. And over here, I know these. So that's like 120, 150. And over here is 180. What other trig functions do I know? Well, I can keep coming around the circle. After 180 is 210, 240. 240 being right here. 270, 300. Scoot this down. It's better lighting here. 300, 315, not 315, 330, and 360. I could keep going around again and again and again and again, but I'll just go with those. That's once around the circle. If I come back, so that's all of these points. I know those. Alright, now there's some that I haven't drawn yet. This point right here, halfway through quadrant 1, is known to me. That's 45. And this one over here is 135. So I usually dot in the quarters. Differentiates. And then down here, 225. 225, and over here 315. Alright, so those are all the ones that I know the sine and cosine and any trig function really of. Now I want those to be listed in radians. So this is pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6 pi, 7 pi over 6, then it's 4 pi over 3, and 3 pi over 2, 5 pi over 3, lost 11 pi over 6, I'm found, and 2 pi. Coming around with radian measures with 45, we've got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So that's quite a lot. I can give you any of these values in radians or degrees and ask you for the sine, cosine, or tangent, secant, cosecant, or cotangent, and you can get those for me. So that's quite a lot, but we're going to add to that list today quite a few. So let's see how that's going to work. We're going to develop our first formula for doing so by looking at this. The sine of a plus b. I'm going to get that back in. Just back down a little bit. There we go. Sine of a plus b. I was wondering if it works like this. Do you think perhaps, I'll put a question mark, sine of a plus b equals sine of a plus sine of b? Real numbers and expressions work that way. But does the sine function of a sum equal the sum of the individual factors or products? Let's say that again. Does the sine of the sum of the sines? That's better. All right, so let's test it with one that we know from our list up here. Let's say sine of 30 plus 60. So the sine of 30 plus 60, does that equal the sine of 30, I'm going to distribute it, plus the sine of 60? So we'll see what you think and see if you're right. So sine of 30 plus 60 is 90. So we know what sine of 90 is. Sine of 90 would be this unit circle over here. So little monkey math. 0, 1 there. So the second coordinate is 1. So we have on the left side, sine of 90 is 1. And we're wondering if that's going to be equal to the sine of 30 plus the sine of 60. So sine of 30 is right there. So that is square root of 3 over 2 1/2. So the sine is 1/2. And no, it is. Yeah, go over square root of 3 over 2 and up 1/2. So the sine is a second. Oh, yeah, 1/2. What about up here? Sine of 60 is up here, so that's 1/2 square root of 3 over 2. So the second coordinate is square root of 3 over 2 at 60 degrees. So is this a true statement? Is 1 equal to 1/2 plus the square root of 3 over 2? Well, we could plug that in a calculator, or just by intuition, 1 plus the square root of 3 over 2. They have a common denominator. So if 1 plus the square root of 3 is equal to 2, then we would have 2 over 2, which would be 1. But is this exactly 2? It would be if this was 1. But is the square root of 3 equal to 1? Is 1 times 1 equal to 3? No. There is a value in between 1 and 2 that when you multiply it times itself, you do get 3. But it's greater than 1. So if this value is greater than 1, I add it to 1, it's going to be a value greater than 2, so it's not going to be equal to 1 on this side. So that didn't work. So even all the way up to the top where we were guessing, is sine of a plus b equals sine a plus sine b? It does not work that way. So let's see what it does do. I was wondering if maybe, just maybe, sine a plus b works like this. Sine of a cosine b plus cosine, cosine a sine of b. Could it possibly work like that? Let's try 1. We'll do sine of 30 plus 60 again. And in this case, we're putting, everywhere we put C and A, we're putting in a 30, and B is being replaced by 60. So going across, A is 30, B is 60, A is 30, and B is 60. Oh, this battery's looking bad. I might be able to plug it up and see. Sine of 90 is 1. And let's see if it works. So sine of 30, we've already sketched that briefly over here. Sine of 30 is going to be, sine of 30 is 1/2. Cosine of 60 is 1/2. Oh, that's interesting. And then over here, cosine 30, where'd my unit circle go, is square root of 3 over 2. And sine of 60. Sine of 60 is square root of 3 over 2. If this video goes out, I will charge it and finish it a little later. So, sorry about that. Now, is this equal? Well, 1/2 times 1/2 is 1/4. Square root of 3 over 2 times itself is 3 over 4. Oh, wow. 1/4 and 3/4 is 4/4. Yay. So, this is your next trig ID. What number is it? Go to your trig ID and see, number it, and write it in. I'm not going to verify the rest of the trig IDs. I'm just going to give them to you. And they go like this. Sine of A minus B. This will be very similar to sine of A plus B, except it's going to be sine A cosine B minus cosine A sine B. So what's the difference between that and that? Just the plus sign became a minus. So if you got a handle on the first one, you should easily get the second. Then cosine of A plus B works like this. Cosine A cosine B minus sine A sine B. And cosine of A minus B is cosine A cosine B minus, plus, because this one was minus, plus sine A sine B. Alright, so let's look and see if we see any trends. So there's 4 to add to your trig IDs. On this one, I notice that I've got this pattern A, B, A, B. And look down here at these 3. A, B, A, B. A, B, A, B, A, B, A, B. So that is a pattern I've noticed. I notice when there's sign, the SIGNs, the plus or minus, match. So this is plus, so is this. And this is minus, so is this. But cosine works the other way. When cosine is positive, the sign in the equivalent ID is negative. And when this is negative, this is positive. I notice this goes sine, cosine, cosine, sine, and so does this, sine, cosine, cosine, sine, whereas cosine IDs act differently. They go cosine, cosine, sine, sine, cosine, cosine, sine, sine. So, am I going to ask you to remember these? I am not, but it is helpful, especially, I'd say especially this one and this one. And if you can remember those two, you can remember all of them, but I'd say those come up, especially this one, more than you would think in higher math, this one up here. So it would be to your advantage to try to commit them to memory. So we'll practice them on the board and see what we can do. Here's how we will use these. And I think I'll shut this down and start my example on the next part.